In this video, we will discuss about merge k sorted list. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So what they are saying is that you are given k linked list in your inputs. All of these are sorted in increasing order. You need to merge all these k linked lists into one linked list, and that linked list should also be sorted, and after sorting it you need to return the head of that linked list as your answer, right? So basically you are given a vector where each element denotes the head of the linked list, right? So basically what will happen is, so see, here node is 1, here node is 1, here node is 2. So in your final linked list, what will be the first node, which is the smallest value? 1, right? So either of these two can be the first node. So let us suppose I am taking this particular node. So my linked list will look like this, right? Now after 1, which is the next node? Again it will be 1, because 1 is equals to 1, so next node will also be 1, right? So here also we will have 1. Now after 1, what do we have? 2. After 1, 2 is node that will come when we will sort this. So this will be 2. Now after 2, this and this are done. Now after this we have 4, 3 and 6. Which one is smaller? 3. So the next node will be 3, right? So the next node is 3. Now this is done, this is done, this is done, and this is also done. Now out of 4, 4 and 6, which is smaller? 4. Let's take this one. So our next node will be 4, right? So this will be 4. Now this is also done. Now we are left with this 5, 4 and 6. Out of this 4 is smaller. So again the next node will be 4, right? So this will be 4. Now we are left with 5 and 6. Which will be the next node? 5. So the next node that we will create is 5. Now after this we are only left with one node, which is 6. So our last node will be 6, right? So this is the final linked list, and this is the head which will denote to this one. This we need to return as our answer. So this is what they are expecting, right? So one of the simple brute force or the naive approach that you can do is that let's suppose you can create an array and you can store all the nodes there, right? And then you can sort that array on the basis of the values of these, right? And then from that array, since it will be sorted, so it will have these elements in the same order in which you want to create your linked list, right? So you can just traverse in your array and you can create this linked list and you can return the head, right? So this is one of the basic approach. But how do we write an optimal solution for this? How are we going to optimize it? Another possible way is that first you merge this linked list with this linked list, then you will get a new linked list, right? Then whatever is that merged linked list out of these two, you can take that and you can take the next linked list and then you can combine these two. Similarly, you will get again a new linked list. Then if there is one more linked list here, then you combine this and this together. And this is how two linked lists at a time you can combine, and at the end you will get your answer. So this is also one of the possible ways, right? Now the other possible way is what? That see, what we want is that every point we want that whatever are the remaining nodes. So if let's suppose I have considered this one and this one, this much linked list I have built, right? So from all the linked lists, what are the next nodes that I have? I have node 4, node 3 and node 2, right? Out of these three, I want whichever is the minimum one. Minimum one is 2. So I know that the next node is going to be 2, right? So when I have taken 2, now I want to consider 6, right? So then I want to check that out of this 4, 3 and 6, which one is the smaller. So basically at every point I am having k nodes, right? Because these linked lists, the number of linked lists are k. So I will be having k nodes, one from each of the linked list, until I have not reached the end of any of them, right? If I am somewhere in the middle, then I will be having max k nodes from all the linked list. Out of that, I want whichever is the minimum one. Then whichever is the minimum one, if I am able to know, I can use it in my linked list. I can create a node for it in my linked list, and then I can move on to the next node of that particular node in my linked list, right? So basically what I'm doing is, if let's suppose I take a min heap, right? If I take a min heap, so min heap is nothing but a data structure which stores some data and it always gives you the minimum value. If you are storing 4, 3, 6, 1, 2 in a min heap, then whatever is the smallest value, which is 1 in this case, that it will return always, right? So if I create a min heap and inside my min heap, I always keep those k nodes which I want to consider at any moment. Then out of those k nodes, it will always give me the node that is having the smallest value, right? So basically what I'm saying is, if let's suppose in this min heap, I have stored the value of my node and the node itself. So basically, I am storing a pair here where the value is the value of the node. So for this particular node, the value is 1. For this particular node, the value is 4. So if I am storing the value plus the node itself inside this min heap, then what it will do, whichever value is the smallest, that it will keep at the top, right? So through this min heap, I can get the node out of my k nodes, which is having the smallest value, right? So basically, initially what will happen is, initially I will keep the head of all the linked lists inside my min heap, right? So what will happen is, we will store this 1, 1 and 2 in our min heap. So here we are storing a pair. So first it will have the value 1, and then it will have the node itself, which is 1, right? Then for this particular node, again it will store 1 and the node itself, which is 1, right? Then for this 2, it will store the value as 2 and the node itself, which is 2, right? So this is what it will store initially. So now our k was 3. We were having 3 linked lists. Of all these 3 linked lists, we are having one node over here, which is the head. And since it is the min heap, then whichever node is having the smallest value, that will be present at the top, right? So here we are having 1. So what we will do is that we will now take out the top element from our min heap, and this will give us the first node that we should create. So here we are having 1, right? So you will create a node 1 over here, right? And then you will remove it from your min heap. So now this node was denoting this particular node, right? So once you have taken this out from your min heap, you should now take this node 4 inside your min heap for further consideration, right? So now what you will do, so whatever is the next node of this particular node, that you will push inside your min heap. So now it will store 4 here, 4 value and the node itself, which is 4, right? So now if you see here, now which is the smallest? Again, it is 1 only, right? So now we'll take this one out and we'll create a new node here 1, and this will be pointing to this node. Now this node 1 was denoting this particular node. So now its next is 3. So we should now push this inside our min heap, right? So our min heap will become 3 comma the node 3, right? Now what is the minimum? It is 2. So we will take 2 out and we will create a new node here, that is 2, right? This 2 was this node, its next is 6. So now we will push 6 inside our min heap. So 6 comma the node 6, right? Now which is the smallest? It is 3. So now we will take this 3 out and we will have a new node here with the value as 3, right? Now after this 3, it was this node, right? So next is 4. So now we will push 4 inside our min heap. So we will have one more entry over here for 4, right? Now which is the smallest? Again this 4 only. So now we will push this 4, right? And it will be removed from our heap. Now this particular node 4 was this node, right? Now you see that we do not have any node over here. Then that means for this node, we do not have anything to push inside our min heap. So we will just move forward. So now what is the top element in your min heap? Again 4. So you will take this 4 out. Again you will have a node here which will be 4, right? And this node 4 was this particular node. What is its next? It is 5. So you will now push 5 inside your min heap. So your min heap will look like this, right? Now what is the smallest value? This 5, right? So you will pop this 5 out. You will create a new node here with the value as 5, right? Now if you see, after this 5 again, we are not having any other node to push inside our min heap. So we will move forward. Now which is the smallest element present in the heap? It is 6, right? So we will take this 6 out now and we will create a node here with the value as 6. Now for this 6 also, we are not having any node to push inside our min heap. So we will move forward. But when we will move forward, you will see that your min heap has become empty. So then that means we have got our answer and we can stop here and we can return this linked list, right? So this was the simple logic that we had to apply. And you have to return this head. This head you need to return as an answer. Now when you will be creating this linked list, you will be taking some pointer, right? So when you would have created this node 1, let's suppose you would have pointed it with some variable named temporary variable. Then when you would have created this node 1, then you would have moved temp here, right? And then when you would have created node 2, then temp would shift here and so on. When you would have created node 6, then your temp would be pointing to this node 6, right? So then that means at the end you will lose the head of your linked list. So you need to store the head of your linked list somewhere, right? So for that, what you can do is, you can create a dummy node. You can create a dummy node. You can give it any value, let's suppose -1, and initially you can point your temp to this dummy node, right? You can point your temp to this dummy node. And now whenever you are creating a new node in your linked list, what you will do? So let's suppose you have created this particular node. Then what you will do is that in your temps next, you will add this node. So what will happen is that this dummy node will now start pointing to 1, right? And once you have done temps next equals to the new node, you will move your temp pointer to this particular node, right? So now this temp pointer will be pointing to this particular node, right? Now when you will create this node, then again what you will do, in temps next you will keep this node, so this will happen, right? And then you will shift this temp, so then temp will point here, and then you can do this process for all the nodes. Now at the end you can just return dummies next, because dummies next is storing the head of your linked list. So through this dummy node you would be able to store the head of your linked list, right? So what is the entire process that we did? We created a min heap which was storing a pair of value and the node, right? Then we added all the heads of all our linked lists inside our min heap. Then we started iterating inside this min heap until it becomes empty, right? So inside this, what we did was that whatever was the top value that we took out and we added it inside our linked list, then we checked that if this particular node which we have added inside our linked list, is its next node present in the linked list or not. If it is present, then in that case we pushed it inside our min heap. And if it is not present, then we move forward. And at every point we were moving our temp pointer also, right? And this entire process was repeated till our min heap does not become empty. And at the end we were simply returning dummies next, right? So let's code it out now. While looking at the code, you will be able to understand better what we are trying to achieve. So as I said, first of all, we will create a min heap, and in C++, min heap is implemented through a priority queue. So in the min heap, we are going to store pair of integer and the list node, right? So first let's define that pair here so that we do not have to write it again and again. So we will write using node pair equals to, so it will be a pair where the first element will be of type integer and the second element will be of type list node, right? Then inside here we will create a priority queue, right, for storing our min heap, and it will be of type node pair. Now by default priority queue creates a max heap, so we will have to write vector node pair comma greater node pair. So this we are doing to create min heap, and we will name it pq, right? Now what we want is we want to insert the head of all the linked lists inside our pq. So what we'll do, we'll iterate from I equals to 0 till lists dot size, right? And we will push the head. Now in some cases you are also given an empty list, right? So if the list itself is empty, then you don't have any node to insert in your priority queue, right? So first you will check that if lists of I exists. If it is not null, then only you push the pair in PQ. What will be the pair? So first will be the value. So it will be lists of I value, and then next will be lists of I. So we are basically pushing a pair which is having the value of the node and the node itself, right? After this, now we will start creating our linked list. So for that we will create a dummy node, right? So dummy equals to new list node. You can give any value over here. Let's suppose I give -1. Then you need to create another pointer named temp which will initially point to dummy, right? Now till your priority queue is not empty, what you need to do is you need to take the top element. Why top element? Because it will give you the smallest node, right? So this will give you the number and the node, right? So this will be pq dot top. Then we can remove it from our pq, so it will be pq dot pop, right? Now what we need to check is that if this nodes next is present, then we should push it inside our min heap, right? So we will check that if nodes next is present, then in pq you push the nodes next value and the nodes next, right? This you push. And then what you need to do is you need to add this particular node inside your linked list, right? So what you will do is in the temps next, you will give this node and then you will move your temp to this particular node, right? And at the end, you can return dummies next, which will be denoting to the head of your linked list. Simple. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.